Okay, so we are today gonna talk about centroids, aka center of gravity. Well, these are the same concepts essentially, with a little slight differences in definition, but they are literally the same point. Like when you look at these pictures here, what I mean by centroid is the middle of the square, as you can see there. Okay, and then each and every shape has its centroid. Triangle, semicircle, quarter of a circle, and all other strange shapes. Semicircle, all other strange shapes. We'll get to explore their centroids. But by the end of this lesson, you should be able to define the term center of gravity and centroid and know the difference between the two, and also know the similarity. Well, we've already mentioned its similarity, that it's essentially the same point. And then you have to be able to determine the centroid of a regular and an irregular shape. By regular shape, I mean like a standard shape, like the ones we just looked at in the previous slides. So those are regular shapes: a triangle, a square, a circle. Those are regular shapes. But an irregular one then is a combination of all of those shapes. Okay, let's get into it. Now look at this. The center of gravity, also known as CG, center of gravity of a body, is defined as the point through which the entire weight of the body acts. Okay, so if you look at my body right now, the part that you see, there is one point where the entire weight of this body acts, like maybe it could be in the middle there, which means that's the concentration of the entire weight of my body in this point. Okay, but the centroid is defined as the point at which the total area of a plane figure is assumed to be concentrated. Okay, it is the center of gravity of a plane figure. So if you look at my figure as well, I mean, just think of me as a 2D, and then this is the area. Okay, so the area of my body is also centered there. Okay, so when you were looking, let's put it this way, when you were looking at my center of gravity, let's say it was in three-dimensional, the center in three-dimensional, it's here. But when you look at a centroid, let's say now we are looking at the actual shape, two-dimensional, and it's still the same point. The only difference, the other one is 3D, the other one is 2D. Well, it's not always like that. It's just an example, trying to make it sound relatable. Again, but essentially a center of gravity of a plane is a centroid. Okay. Now, a center of gravity of a rectangle is the point where the diagonals meet. Yes, because the diagonals are in the middle. When we're talking about diagonals, we're talking about lines like that. But anyway, well, I'll demonstrate it later in the next slide. And then the center of gravity of a triangle is a point where the medians meet. The medians meet. Okay, remember that. The center of gravity of a circle is at its center. Wow, circle has one center. Let's look at all of this. Let's look at all of this. Okay, let's consider this right here. Now, a centroid, it is defined as a point. These are just differences between centroid and center of gravity. Defined as a point about which the entire line, area, or volume is assumed to be concentrated. So pay attention. It has to do with the line, an area, and the volume. Okay, so remember, let's say a line is one-dimensional, area two-dimensional, and then a volume is three-dimensional. There was a centroid. But what about center of gravity? It is defined as a point about which the entire weight of the body is assumed to be concentrated. So now the center of gravity has to do with the weight. Okay, like I said earlier, if you look at my body, and then the entire weight is concentrated here. But now that is the center of gravity of my entire weight. Okay, and the entire weight, we can say it's three-dimensional. But when we look at the centroid, really, then let's just look at the area of my body. It's the same point, just a difference in terminology. Okay, so the centroid is related to the distribution of length, area, and volume. Okay, it has to do with, just think of an area, and then one step up for an area is volume, and one step down for an area is a length. Okay, and then center of gravity is related to the distribution of mass. Okay, so mass has to do with weight. The difference between a mass and a weight is that weight includes the gravitational acceleration, which is 9.8. But that's science now. Okay, let's move on. So, centroid of a rectangle, as you can see here, it's right there in the middle. The diagonals, they meet there. Diagonal, diagonal, they meet there at the center. So it's a distance of, if you're looking from the right, and that's your base, it's half base. And if you look at the height, half height. Okay, so the distance is from half base to half height. Now let's look at the circle. The circle over here, if you look at this circle, right, its center is there. The center just so happens to be also, you know, the centroid as well. Okay, now let's look at a triangle right here. Triangle, this is a right angled triangle. Its centroid is at a distance from the left here. When you're looking at this point, it's distant at a third, 1/3b. And also, when you look at the height, it's from a third of a height. Then you see it's there. But if you're coming from the apex, like on the one on the left, on the right, then it's 2/3 from the apex and 2/3 from the top of the height. So it depends from which position are you looking at, but it's always nicer to look at it from this position here that is shown here. It's third away from that position, third away from the right angle position. Now if we look at a circle, or let's look at half a circle rather, we've looked at a circle. This is half a circle, so yes, its distance at radius, okay, which is at the center when you look at the base part. But when you look at the height part of the half a circle, then it's at a distance of 4r, which means 4 times the radius divided by 3 pi. Okay, so those are the distances. Those are the centroids, the distances of the centroids. I hope those are clear. But if they are not, then let's do a quick, we'll need to do a quick calculation just to make sure that you understand these things. So what I have here is an irregular shape, because the previous ones, those were regular shapes. Now these are irregular shapes, which means a combination of shapes. So what we have here is that we have a rectangle first, and then we have a triangle next to it. A is a triangle, and then B is the rectangle. C, whenever you have a shape within a shape, that means it's hollow, which means C is hollow. Okay, it's a shape within a shape, so it's a hollow space, which which means we'll have to subtract it. But if it's next to the shape or on top of it on the side, then it's an addition. Okay, so C is hollow, D, as you can see, is half a circle, and E is also half a circle on the right. Now, what I did this by hand. Okay, so what I'm gonna do is I'm gonna share the video of this. Okay, so I've recorded myself doing this problem for you, this calculation. So what I'm gonna do is just share that video right now, doing that calculation. Then at the end, we'll come back and then, you know, finish up and say goodbye properly. Okay. All right. Okay, so let's go to that video at this point. Oh, let me make sure the sound is on. Include the sound. There we go. All right, let's play that. Let's go to the question now. The question is, the figure below shows a plane lamina. Calculate the centroid of the lamina. Lamina is this whole shape that you can see there. It consists of triangles, rectangles, as well as half circles. Now, there are a few things that you need to know before you tackle this question. The first thing you need to know is the individual centroids for each of the shapes. Let us start with a triangle. The triangle centroid is located right there. From the bottom, it's at a distance of half h, h being the total height. My bad, it's one third of h, not half. And then from this side, it's also a third, 1/3 length. It's called the length, that whole section there. And for a circle, we have a circle, centroid is right there. Okay, and it's at a distance of r. But for a half circle, it's somewhere there. So that's a distance of r, which is the radius. But going up, it's 4/3, okay, r over pi. All right, and then the last one is a rectangle. The centroid is right there at a distance of a half of the length and a half of a height. Those are the few basics that you need to know to tackle this question. Now, we have a table to fill up. There's our table. It consists of the shape, the area, the centroid of the individual shape on the x-axis and on the y. And then we have the moment here, which is the area times the centroid, as well as here. Okay, let's start with shape A. If we go to shape A, as you can see from my lamina, it is a triangle. Okay, and we know that the area of a triangle is equal to half base times height. So what are we going to do? We're going to take a calculator and put this into a calculator. We're going to say half, let's switch calculator on, which is 0.5 times the base. Our base is 30 times 30 times a height of 35, and we get 525. Take that answer, put it 525 right there. The next shape is B. B is this entire rectangle, which is 40 times the distance of 40 again, which is 35 plus 5, it gives us 40. We put that in our calculator. We get an area of 1,600. Take that and put it there. Okay, now for C, we go to C. C is a triangle. In our area, once again, half base. Our base is 15. Times a height of, we're given a height of 10. We get 75. Now, what you must know is, if you have a shape within a shape, that shape is hollow. So, since this is hollow, C is hollow, we put it as negative. It has a negative area. It's an empty space. Okay. But if you have a shape besides a shape, besides a shape, besides a shape, then you add that one. But if it's within a shape, then it's always hollow. Okay, now let's go to D. Where is our D? D is there. Okay, the area of a circle is pi r squared. But the area of a half a circle is still pi r squared, but it's divided by 2. So, since D is half a circle, we're going to say pi times our r, we're given as 10 squared, divided by 2. We get 157. We'll go ahead and put it right there. 0.08. And then now we go to our shape, which is E. It's also half a circle. So we're gonna just say pi times our r, we're given an r of 20 squared divided by 2. That gives us 628. Take that 628.32. Okay. Now we need to find the individual centroids on the x-axis, starting from, this is our datum, 0. So everything will be based on that. Okay, so the centroid of A is a triangle, and if coming from this side is 1/3, then coming from the apex this side, it is 2/3. times L. Likewise, up there, it's going to be 2 over 3h. That's that distance from here to here, and here to there. And we have that situation here where the centroid of this triangle is somewhere here. So we're going to take our calculator and we're going to say, okay, 2 divided by 3 times a length of 30. And we get 20. Take the 20, write it down there. Okay. Now, B is a rectangle. Okay. And the centroid is at half its distance, as we had said there. So, half of 40 is 20. It's 20 there. So we're going to say 20, but to take us back to the datum, we need to add this 30. All right, so it's 20 plus 30, which equals 50. Take that 50, write it down there. Okay, that is our B. And for C, our centroid is also there. Okay, so we're going to take half of 15, which is 15, all right, divide by 2, we get 7.5. So it's 7.5 there, but we need to add this 10 and add that 30. So we're going to say plus 10 plus 30, we get 47.5. Take that 47.5, put it there. Okay, now C, we're moving to D. D, the centroid of D is just a radius of 10, so it's somewhere, it's there. So it's 10 plus, to take us back to the datum, 30. That's 40, which gives us 40. Write the 40 there. And of E, remember we spoke about it, that's the centroid is somewhere there, but that distance from there to there is given by 4r over 3 pi. So we're going to say 4 times the r we're given is 20 times 20 divided by 3 divided by pi. And that's equal to 8.48. But that's just that distance from there to there. To take us back to the datum, we need to add this entire 40 plus that 30. So on this answer, we're going to say plus 40 plus 30. That gives us 78.84. Take that 78.84. We'll round it off to 49. Okay. Now we need to look on the y-axis. Okay. Starting at A again. We know that the distance from there to there is 1 over 3, as we had discussed here. So we're going to say 1 divided by 3 times the height we're given is 35 of the triangle, times 35. And we get 11.67. Take it, write it down here. Okay, now B is a rectangle, and it's just at height of half of 40, which is 20. So take a 20, write it down there, and then the next one is C. C is that triangle there. So from there to there, we discussed it, it's 1/3. So we take our calculator again, go 1 divided by 3 times the height of the triangle is the height of 10, and we get 3.3. But to take us back to the datum, we need to add this distance here, and we are given it is 5. So we're going to say plus 5, and we get 8.33. Take that 8.33, put it there. And then of D, we discussed it before, that centroid there is at a distance 4r over 3 pi. So take our calculator, 4 times r is 10 divided by 3 divided by pi. We get 4.2. But that's that distance from there to there. We need to add from here to here. Takes us back to the datum, so we're gonna add plus 40. It gives us 44.24. Write it down here. Right, and then the last one is E. E is this one. It's just basically the radius, which is a distance of 20. So we write the 20 here. Right, the rest is much more simpler. We just need to look at the table. A times X. So it's area times the X part, and it's in millimeter cubed because I'm multiplying a millimeter squared times a millimeter. So for the first one, we're just simply gonna say 525 times 20, and we're gonna get 10,500. Write it down here. The next one is gonna be 1,600 times 50, 80,000. The next one is negative 75 times 47.5. We get negative 3562.5. Okay, the next one is 157.08 times 40. You get 6283.2. The next one is 628.32 times 78.49. Get that big number there. Four 950.5.33. Okay. The next one is A times Y. Area times that Y component. First one is 525 times 11.67. We get 6126.75. The next one is 1600 times 20, 32,000. The next one is minus 75 times 8.33 minus 624.75. The next one is 157.08 times 44.24. Get 6949.22. And the last one is 628.32 times 20. Okay. 1, 2, 5, 66.40. The next thing to do is to sum our area, the total area, which is this column. It's 525 plus 1600 plus, or let's just say negative, minus 75 plus 157.08 plus 628.32. We get a total of 2835. We don't need to sum that. We don't need to sum that, but we do need to sum these numbers. So we're gonna have 10,500 plus 80,000 minus 3562.5 plus 6283.2 plus 49,505.33. Get that big number, 142,726.03. Add these ones here. 6126.75 plus 32 minus 624.75 plus 6949.22 plus 12566.40. 57017.62. Now, to get the actual centroids, we're gonna underline there. We're gonna take this number and divide it by that number. Okay, if you look, you have ax divided by a, then you will be left with x. The a cancels that a and you're left with the x component. So I'm gonna say 142,726.03 divided by 2835.4. We get 50.3. Rounding it up. So that means that our centroid on the x-axis is located the distance of 50.34 from the datum. And then we're going to do the same for this side. We're going to say 57,017.62 divided by 2835.4. You get 20.1. There it is. 20.11. All right, now that concludes our session. We have found the centroid. It's located at 50.3, so it's somewhere there. 20 there, 30 there, somewhere there. And then on the y from here it's 20.1, so it's somewhere there. So the centroid, final centroid, is somewhere in there. Well, I hope you have learned something today, and that going forward you will excel in this question. Well, that's it. Well, I sure hope you understood everything that I was trying to explain over there.